On page 161 in your student journal, we're going to learn about independent and dependent. So for exploration 1, determine which events are independent or dependent. And the definition is right above that. Two events are independent when the occurrence of one event does not affect the occurrence of the other. And two events are dependent events when the occurrence of one does affect the occurrence of the other event. So, when we roll two six-sided dice, does the number on the first dice affect the number on the second dice? No. So if I get a 4 on the first dice, does that tell me anything about what's going to happen on the second dice? No. So those would be independent. Okay, B, 6 pieces of paper numbered 1 through 6 are in a bag. 2 pieces of paper are selected one at a time without replacement. What does without replacement mean? You don't put it back in. So you draw one and you set it down. That's your first number. Then you reach in, you draw another one, and you set it down, and that's the second number. Does the value of the first number affect the value on the second number? Yes. How come? If you draw out a 5, what do you know about the next number? It's not going to be a 5. Those are dependent. The first value does affect the second value. So if you play the lottery, where they pick 6 ping pong balls out of the bin, does the value on the first one affect the value on the second one? Yes, because if you get a 12 on the first number, you can't get a 12 on the second one. Those are dependent. Okay. There's a really famous story that happened in Europe almost 100 years ago, in the 1920s, I believe. And there's a little tiny country in Europe called Monaco. You ever heard of this place? It's just tiny. It's probably the size of Castledale. Maybe a little bit bigger, but it's really, really small. And it's known as the gambling hub of Europe. Okay? In the 1920s, people were playing roulette. And a roulette has 18 red spaces and 18 black spaces and then 2 green. And people like to bet on red or black. Okay? Well, I don't remember which color it was, but we'll say black. Black happened like 29 times in a row. And people lost millions of dollars. Millions of dollars in that one 10-minute period. Because they'd spin it and it would end up on black. And then it got black and black and black and black and black. And people started saying, oh, black has happened so many times, red is bound to happen next. Is that true or false? Well, is getting black on one game dependent or independent of what happens next? Totally independent. So your chance of winning is always around 50%. It's actually a little bit less than 50% because of the 2 green squares. But it kept happening over and over and over, and so people started betting thousands, tens of thousands, hundreds of thousands of dollars because they expected red to happen. And it didn't happen for 29 plays in a row. And as far as we know, that's never happened at any other moment. But the casino made a lot of money because people just kept saying it's bound to happen. But no, they're independent events. The chance of getting black on any game is the same as any other game, no matter what has happened in the past. So, well, eventually, yeah. I doubt it. I imagine that most people who were still there were pretty broke. So I don't know the end of that story, how much was won in the end. But overall, the casino won millions of dollars. Millions and millions. It was, and that's back in the 1920s. So, okay, exploration 2. Estimate the probability that the sum of the 2 numbers rolled is 7. How would we do that? If we roll 2 dice, how are we going to figure out the theoretical probability of getting a 7 when you add them together? Well, how many combinations are there? When we roll 2 dice, what could happen? I could get 1, well actually 1 and 1. So I could get 1 and 1. Let's just do this. We'll say 11 or 12 or okay, then what? 21, 22, 23, 24, 25, 26. Now I'm getting lazy. Dot, dot, dot. 61, 62, 63, 64, 65, and 66. So how many ways are there, or how many outcomes are there? If I filled out that whole table, how many possibilities are there? 36. Now, are 12 and 21 the same thing? Are they the same play? They both add up to 3, but why are 12 and 21 different? They're different dice, and whenever you roll dice or flip coins, remember, think of the dice as different colors and the coins as different coins. So we have a red dice and a blue dice. So 12 and 21 are 2 different options. Okay, so there are 36 total options. And what are we looking for? The ones that add up to 7. So how many of them, or sorry, which ones will add up to 7? So the 1 and the 6, the 2 and the 5, 3 and 4, 4 and 3, 5 and 2, 6 and 1. So what's the probability? 6 out of 36, which turns into 1 out of 6. You have a 1 in 6 chance when you play Monopoly to move 7 spaces. Okay, that's actually the highest probability. What's the probability of moving 2 spaces? How many ways are there to get 2? Just 1. 1 and 1. How many ways are there to get 12? Just 1. So this adds up to 2, and this adds up to 3, and this is going to add up to 4, and this is going to add up to 5. So we have 1 way to do this, 2 ways, 3 ways, 4 ways, 5 ways, 6 ways to get a 7, and then we would do 5, 4, 3, 2, 1 again. Okay, B. Estimate the probability that the sum... Oh, so in part B, we're no longer rolling dice. Now we're just picking numbers out of a box. 1, 2, 3, 4, 5, 6. What could happen if we draw these numbers without replacement? What would the first one be? We're drawing twice. 1, 2. Why not 1, 1? Because I'm not putting anything back in. I'm going to reach in, pull out a number, set it down, reach in, pull out another number, and set that one down. So I cannot get 1, 1. Why not? There's only one number in there that is a 1. So that doesn't work. So we'll do 12, 13, 14, 15, 16. What would the next row be? 21. Can 21 happen? Yeah, it can. So 21. What about 22? 22 can't happen. So 23, 24, 25, and 26. Okay? Now I'm getting tired of doing this. 61, 62, 63, 64, 65, and there's no 66. How many total options are there? There's 5 in each row, and there are 6 rows, so there are 30 total ways to do it. How many of them are going to add up to 7? Well, 1 and 6, 2 and 5, 3 and 4, 4 and 3, 5 and 2, and 6 and 1. So what's the theoretical probability of pulling out 2 numbers that add to be 7? Well, there are 6 of these over 30, which is equal to 1 out of 5. Is that a better probability or a worse probability than the last problem? It's actually a little bit better. 1 in 5 is a better chance of winning than 1 in 6. Okay? How many numbers did I eliminate when I switched from A to B? 6 of them. What were they? All of the doubles. So when I switched from rolling dice to drawing numbers without replacement, I no longer have 11 or 22 or 33 or 44, 55, or 66. Does that make sense? I got rid of all of the doubles. Well, how many doubles are there? 6 of them. Which is why this number switched from a 36 to a 30. But when you add up to 7, there are no doubles. Right? We have 16, 25, 34, 43, 52, and 61. There were no doubles in that list. Okay. So number 3, turn the page. Find the theoretical probability that the sum of the 2 numbers rolled is 7. Wait a minute. Expression A. We just did that, didn't we? Oh, we were supposed to do experimental. Oops. We were supposed to play the game. That's my fault. All right. So go down to 4. How can you determine whether 2 events are independent or dependent? Does the chance of the first one influence the chance of the second one? That would be, if the answer is yes, they're dependent. If the answer is no, they're dependent. So does the chance of the first one influence the chance of the second one? Okay. Look at number 4 or 5. Determine whether they are independent or dependent. So letter A, you roll a 4 on a 6-sided die and spin red on a spinner. Are those independent or dependent? Does the number on the dice affect the color on the spinner? No, they're totally independent. The dice has nothing to do with the spinner. Okay. Your teacher chooses a student to lead a group, chooses another student to lead a second group, and chooses a third student to lead a third group. Independent or dependent? Dependent, why? Right. The choice of the second leader depends on the choice of the first leader. Because once the first leader is chosen, that person can no longer go in the second group or the third group. Okay? All right. I think we're moving on to the text. All right, 5.2, example 1. This is on page 288. A student taking a quiz randomly guessed the answers to 4 true-false questions. Use a sample space to determine whether guessing question 1 correctly and guessing question 2 correctly are independent events. Does the answer on question 1 affect the answer on question 2? No, those are independent events. Okay, so what would the sample space look like? Well, it would be true, 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 and then we could do 1 false, false, true, 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 false, true, true, and then true, true, false, true, and then true, 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 false. Now we have to do 2 falses. So false, false, true, true, false, true, false, true, false, true, true, false, and then true, false, false, true, true, false, true, false. What am I missing? So I have every place where false is first. Oh, I need 2 falses at the end. True, true, false, false. Okay, I can stop there. How come? How many will there be that have 3 falses? The same as 3 trues. So this next line is going to have how many in it? It's going to be the same as this line, because that line has 3 trues. So the 3 falses are going to be the same. Are there any more? All falses. So there'll be 4 in this line and 1 in that line. So that's 1, 2, 3, 4, 5, 6, 10, 14, 15, 16. There are 16 possibilities. And these are independent, right? So we want to find the probability that we end up with guessing correctly on the first one and guessing correctly on the second one. Okay, well, if we add it all up, I guess we didn't want to do falses and trues. We wanted to do right and wrong. Okay, if 2 events are independent, if the first one does not affect the second one, then you can multiply the probability of the first one and the probability of the second one. So look at that formula under core concepts. See how it says the probability P of A and B equals P of A times P of B. So this is probability notation. So the probability of A and B equals the probability of A times the probability of B. But this only works if A and B are independent. If they're not independent, then it falls apart. Okay? So if you are guessing true or false, what is the probability that you get the first one right? If you just have to randomly guess on question 1, how many of you will be right and how many of you will be wrong? What would we expect? Well, how many options are there in a true-false question? 2. How many of them are correct? 1. So the probability of A is winning 1 out of 2 times. Okay? What's the probability, what's the probability that you get B correct? 1 out of 2. Are A and B independent? Yes, question A has a 50% probability and it has nothing to do with question B. So what's the chance that you get them both right? Well, you take this one and you multiply it by that one. So 1/2 times 1/2. 1 times 1 is 1. 2 times 2 is 4. You have a 1 in 4 chance of getting them both right. Okay? All right. Example 2. A group of 4 students includes 1 boy and 3 girls. The teacher randomly selects one of the students to be the speaker and a different student to be the recorder. Use the sample space to determine whether randomly selecting a girl first and randomly selecting a girl second are independent events. So, so we want to know, is selecting a girl first dependent or independent of selecting a girl second? Dependent. How come? Whoever gets picked first can't be picked second. Okay, so that is a dependent event. Okay, over on the right side, finding probabilities of events. In example 1, it makes sense that the events are independent because the second guess should not be affected by the first guess. In example 2, however, the selection of the second depends on the selection of the first. So can Malia be picked second? Yes, as long as she didn't get picked first. That is a dependent situation. Okay. So the probability that event B occurs given that A has occurred is called the conditional probability. Okay, a conditional probability of B given A is written as the probability of B slash A. Okay, that is a conditional probability, and we'll get into that in a little bit. So for today, I just want you to do well, our assignment is going to be 3 through let's do 3 through 25, and you should be able to get about that first page done today. So 5.2, 3 through 25, all. So all you're doing from 3 through 10 is determine, are they independent or are they dependent? So get that first page, get 3 through 10 done today, and then we'll move on to calculating some of those probabilities. And we'll finish the rest of this tomorrow.